Hi everyone. Example 17. A venturi tube discharges water from a reservoir. The diameters at the throat and at the outlet are 75 millimeters and 100 millimeters respectively. Neglecting all losses, determine the maximum head under which this tube will flow full throughout its length. So this is a diverging tube, and we have two sections, 1 and 2. We call this venturi tube. Diameter 1 is 75 mm diameter, diameter 2 100 mm. This is the head, and we are asked to compute for a maximum head possible, so that at sections 1 throughout this diverging tube, the liquid flowing or water flowing will be full. So meaning to say coefficient of contraction should be 1.0, and therefore the coefficient of discharge should also be 1.0. So first, we write energy equation between points 1 and 2. So at 1, the datum would be through 1 and 2, so that elevation heads will be 0. Of course, neglecting losses because it is the instruction here. So velocity head at 1 plus pressure head at 1 plus elevation head 0 equals velocity head at point 2 plus pressure head 0 exposed to the atmosphere plus elevation head 0. So replacing V1 by 4Q over pi 0.075 square, then quantity square over 2G or 19.62 plus P1 over specific pressure head in terms of water equals 4Q over pi 0.1 square over 2G. Simplifying, but before we simplify, since this is greater than this term here, it means that pressure head at 1 must be negative. And since we are asked for maximum head, then for the result to be maximum, the discharge to be maximum, so that head will also be maximum, P sub 1 should be negative as possible. So the possible negative pressure will be perfect vacuum, and that is negative 101.3 kilopascals. Then substitute, so 2611.42 Q square plus negative 101.3 divided by 9.81 equals 826.27 Q square. Simplifying, so 1785.15 Q square equals 10.326. From here, we can compute Q, 0.07606 cubic meter per second, and we equate it to, as in we treat this as an orifice with diameter outlet 100 mm. So 0.07606 equals pi 0.05 square area times square root of 2G H, and this should be greater than pi area at the outlet square outlet, then square root of 2GH. So H should be less than equal to 4.780 meters. So that's the answer.